Bismillahirrahmanirrahim. Chapter 23, Algebraic Fractions, Lowest Common Multiple or Least Common Multiple, Exercise 23. So this is our main objective, that how can we find the LCM of algebraic expressions. Let's start with the help of an example. For example, if I want to find the least common multiple of 4 and 10, so there are two methods. The first method is you can list the multiples of 4. Like when I say list the multiples of 4, it means write the multiplication table of 4. So 4, 8, 12, like this you can continue. So here I have written all the multiples of 4. Clearly you can see that we have 20 here and 20 here. So the common multiple is 20, and then we have 40 here and 40 here. So we have another common multiple. But because we are finding the lowest or the least common multiple, so the least common multiple of 4 and 10 will be 20. Right? Okay, what is the other method? The other method is using the prime factorization. For example, the prime factors of 4 are 2 times 2 and the prime factors of 10 are 2 times 5. So we can say 4 equals 2 to the power 2 and 10 equals 2 times 5. Now to find the LCM, we take the common and uncommon multiples of from both the lists. So here 2 to the power 4 and here 2 to the power 2 and here 2 to the power 1. So we have to take a factor that occurs the most. So from 2 to the power 2 and 2 to the power 1, 2 to the power 2 is occurring the most. So we will choose it. And from here 5 to the power 1, but here 5 to the power nothing, like we don't have any 5. So this is the one that is occurring the most. So you will take 5. Now 2 to the power 2 means 2 times 2 and times 5. So your final answer will be 20. Now you can use any of these two methods, the one that is easy for you. But remember, whenever we are choosing from here, let's say from the factors, we choose the one that comes with the greatest exponent, or you can say that occurs the most. Okay, if you look at the second example, it says what is the LCM of A, B. This is one term and the other one is C, and we want to see. Okay, if I look at A, B, what are its factors? Its factors are A times B. And if I look at C, it has only one factor, that is C. So to find the LCM, I have to take each you can say factor that is occurring the most. So if I take A is happening only once. If I look at B, it's happening once or it's occurring once, and C is occurring once. So finally the LCM will be A, B and C. Let's see some more examples. Here, for example, if I want to find what is the least common multiple or LCM of these two, so remember, first I will see what are the numbers. Or you can say what is the coefficient here. So it's 4 and 6. I will think that what is the LCM of 4 and 6. Now it's your choice. You want to go with the prime factorization like I did here, or you want to list the multiples of 4 and 6. It's all your choice. But I want to go with the listing of the multiples of 4 and 6. So the multiples of 4 and 6, I can see that 6, 12, and then 18, and when I write the multiplication table of 4, so it's 4, 8, 12, and clearly 12 is the least common multiple. So 12 will be the when I want to write the least common multiple, so for 4 and 6, 12 is the least common multiple. Then I will look at the same value. So it's x to the power 2 and here x to the power 3, means I will look at the same variables. So x to the power 2 and x to the power 3, which factor occurs the most or is with the greatest exponent? X to the power 3. So the next one will become x to the power 3. Then I will compare y5 with y2. So which one is occurring the most or which one has the greatest exponent? It's y5. So I will take over here y5. So finally the answer will become 12x cubed y5. Right? Okay, now look at the examples here. If you want to find the LCM of A, B and A to the power 2, so look at this. If I break A, B into parts, it's A and B, and A squared means A squared. Now which one is occurring the most? If I compare the A's, so A squared has the greater power, so I will take A squared. right? And if I look at the b, this one has b to the power 1, this one has no b, so it means I have to take the one that is with the greater power. So this will be the final answer, a squared b. Now the second example, it says 2 x and 6x. So if first I will find what is the GCF of LCM of 2 and 6. Obviously it will be 6, because 6 can be divided completely by 2. So to find the LCM of 2 and 6, it will be 6. X and x, both are occurring, both of them, they have the power 1. So x is going to be we have to take the one that comes with the greatest power. Right now they have the same power, so it means that I can choose one of the x. Now let's solve some questions from the exercise. Let me see which one is a little bit difficult. I'll solve that one for you, and the rest I want you to solve on your own. Okay, look at, let's say, question number 18. Here the constant number is 3, and here let's say the number is 1. So for 3 and 1, obviously when I want to write I want to find the LCM. So 3 power 1, and here 3 power nothing, right? So I have to take the one that comes with the greater power. When I take the p, this one, it does not have p, so p to the power 1 is greatest here, so I have to take it. Q here, q to the power 1 and q to the power 2, so I have to choose the one that comes with the greatest power, and this will be the final answer. Now better pause the video here and solve the rest of the questions on your own, and then play the video to check your answers. So here are all the answers, students. Clearly you can see for this question number 26, I wrote the multiplication table of 5, or you can say the multiples of 5, then I wrote the multiples of 3. I found 15 is the common multiple, and then y is y to the power 1, y to the power 1 is the same, so it's going to be taken once, right? Here in question number 27, I wrote the multiplication tables of all 4, 3 and 2, and I found that 12 is the least common multiple, and when I look at the x, all the x are exactly the same power, so x will be the part of the LCM. That's all for this video. We need, by the way, we need to understand how to find the LCM for the next exercise, because in the next exercise we are going to add and subtract the fractions, right? And always whenever we want to add or subtract the fractions, the first step is always to find the LCM. That's why it's very important to understand this idea. That's all for this exercise. Hope you understand it.